Welcome to the LMWC Learning Mathematics with Ms. Choekyi channel. Please do hit the like button and subscribe the channel.
Hello everyone. So today we are going to start chapter number 3, which is pair of linear equations in two variables. So until now you must have gone through the linear equation in one variables where you have seen an equation like this: x equals to 4 or y plus 3 equals to 3, something like this, where in each of the equations you will find only a single variables, right? But now you're going to see both the x and y together, something like this. So in one single equations, you will see both x and y. So such equations are called linear equation in two variables. And if you have a pair of it, which means that the second equations also contains the same variable x and y, then this will become a pair of a linear equation in two variables. So the general form of a pair of linear equations can be represented in this way, where a, b, c, all these a, b, c are real numbers, and the coefficient of x, which is a1, coefficient of y, which is b1, similarly a2 and b2, they can never be equals to 0. So they have to be a non-zero number, all right? So why? Because the moment the coefficients of x and y are 0, this whole equation will not be a linear equation in two variables. So let's say that in the first equations, a1 is equals to 0. So let's say coefficient of x is equal to 0. So what will happen is these equations will be b1y plus c1 equals 0, because the whole term, if you take the a1 as 0, so 0 times x is equal to 0, so this whole term will become 0. So you are left with only this. And here only the variables we can see is variable y, and that leads to the linear equations in one variables, right? So therefore you have to keep it in mind that the a1, a2 and b1, b2 are always non-zero. So that is the general form of a pair of linear equation in two variables. So the next topic, we have methods to solve a pair of a linear equation. So we have two methods, and they are graphical method and algebraic method. So in graphical method, we are going to plot the pair of linear equations on a graph, and we are going to see three ways to represent the pair of linear equations on a graph. And based on the formation of the graph, we are going to determine the number of solutions of that particular pair of a linear equation. So we know that linear equations, when you plot it on a graph, you are going to get a straight line. And since here we are talking about a pair of linear equations, which means two linear equations, we are talking about two linear equations. So therefore, we are bound to see two straight lines on a graph. So when you have two straight lines, so there are three possibilities. The first thing can be that the two lines may meet at one single point, and they are called intersecting lines. And as you can see here, this particular dot, this is the point at which the two pair of linear equations are meeting, or they are intersecting. So that this particular point will be the one single unique solution of the pair of linear equations. So that is the first one. Then second one is, when you represent the pair of linear equations, you might get a parallel lines. So since parallel lines never meet, which means that we are not going to witness a solution over here, and therefore the second one is no solution, since they are parallel to each other. Now the third one is that when the two lines are overlapping on each other, then they are coincident. And since the two lines are being overlapping, therefore all the points at which it overlaps, they are the solutions. And since there are lots of many points on the overlapping straight lines, therefore it will have infinitely many solutions for the coincident line. So this is about the graphical method. So next, moving forward. So second method is algebraic method. So Based on this year's syllabus, we have two different methods under the algebraic methods. Then they are substitution method and elimination method. So in substitution method, what we are going to do is from the given pair of linear equations, we are going to take one of the equation, and from that we are going to derive the value of x, and we are going to substitute the value of x into the second equation, and we are going to simplify it to get the value of y, and then we are going to put the value of y into the derived x value, and hence we are going to get the x and y. So to make it more clear, we are going to follow this example. So in this example, as you can see, we have a pair of linear equations over here, and the first equation is named as equation number 1, and second is equation number 2. So here what we have done is from the equation number 1, we are going to derive the value of x, so which means this particular x, I'm going to keep it on the left hand side, whereas this negative 15y, I'm going to take it to the right hand side. So when you take a negative 15y to the other side, it's going to change the sign to plus. And now this equation, from equation number 1, we have derived the value of x as 2 plus 15y, and name this equation as equation number 3. So this equation number 3, I am going to put it into the equation number 2. So here what we are doing is we are substituting the value of x as 2 plus 15y into this x. Okay, so here what happened is 7 times. So in the place of x, I'm just going to replace it as 2 plus 15y, and the rest I'm going to write it as same. The next what we are going to do is we are going to remove the bracket, which means I'm going to multiply 7 to the 2 and again 7 to the 15y. After that, I am going to simplify the y terms, and then we are going to get the value of y as minus 11 by 107. Now since we have got the value of y, so this value of y, we are going to put it in the equation number 3. So because we need the value of x also. So already x, we have mentioned it as x is equals to 2 plus 15y. So in this particular y, we are going to replace minus 11 by 107. So again, we are doing this substitution over here. So in place of y, just put minus 11 by 107 and simplify it, take the LCM, and you are going to get the value of x as 49 by 107 and y as minus 11 by 107. So in this method, you are just going to substitute the values of x and then find out the value of y, and once you have got the y, you're going to take the value of y and put it into the x form, and then again try to get the value of x. So overall, we are doing the substitutions over here, and thus this is called substitution method. So in the second method, which is elimination method, so as the name says, we are going to eliminate one of the variables from the pair of given linear equations. So here I have taken the same example as the previous one. So here again, we will name it as equation number 1 and 2. Now, before, what we done is we were doing the substitutions. So equation number 1, we are trying to derive the value of x. But in this, what we are going to do is we are going to make the coefficients of x as similar. So in this example, I have tried to make the I've tried to make the coefficient of x as same, but for you, you can do as per your choice. So the actual method is that we have to make one of the coefficients of either x or y as similar so that you can eliminate it, right? Now here what I have done is the equation number 1, the coefficient of x is 1. And in equation number 2, the coefficient of x is 7. So what I've done is I have tried to multiply equation number 1 with 7. So the moment I multiply equation number 1 with 7, what will happen is the coefficient of x will become 7x. And similarly, this 7 has to multiply to the minus 15 as well as 2. So once you do that, the equation number 1 will be converted into this, and you will have to name it as equation number 3. Now for the second equations, you need not have to do anything. You're just going to take it and put it under this. And now since the coefficient of x is similar, 7 and 7, while y, the coefficient of y is different. It has to be different. So now since both are positive, positive, so positive and positive, you're going to add it, which means that x is not getting eliminated. I have to make this x as 0. So in order to do that, I have to get -7. So which means I am going to subtract this particular equation. So in order to subtract the equations, I have to change the sign of it, which means I am going to change the sign of these bottom equations. So when you change the sign, so you have to make sure that the sign on this particular equations has to be the opposite of the whatever sign you're going to choose. So since this 7 has positive, you're going to replace it with negative. This is positive, you're going to replace with negative. Since similarly, this is positive, you're going to replace with negative. Now what happened is the second equations will look like this. Minus 7x minus 2y equals minus 3. And equation number 3 is already up here, which is 105y equals to 14. Now, if you simplify it, what happened is x and x both are like terms. So like terms, you can simplify it. So plus 7 and minus 7, it will be 0. So 0 times x is 0. Similarly, for the second one, y and y are like terms, so you can simplify it. Negative and negative, you're going to add it, so it will be minus 107y, which is equals to plus 14 and minus 3. You're going to do the subtraction, so therefore it will be positive 11. So next you're going to derive the value of y, which is equals to minus 11 by 107. Now you have got the value of y, so now your job is to find the value of x. So to get the value of x, you're going to take the value of y and substitute it back into the first equations at which you have tried to change the equations. So you have multiplied the first equation with 7, so therefore equation number 1 is the one which you are trying to change it. So that in that equations, you're going to put the value of y as minus 11 by 107. So when you replace it, you're going to get the answer as 49 by 107, and hence you have got the answers. So what we have noticed here is whether you do this elimination method or the previous method, which is the substitution method, you are going to get the same answers, right? So here x is 49 by 107 and y is minus 11 by 107. Similarly, here also we have the same. So this indicates that whichever method you use, you are going to get the same answers. So if in the particular questions it has been stated that you have to use this particular method, then you will have to use it. Otherwise, if the question says you have to solve this particular questions and they did not mention under which method you have to solve it, then it is as per your choice. Whichever is convenient for you, you can use it. So the last topic of this chapter is to determine the number of solutions using ratios of coefficients. So based on the ratios of the coefficient, we can determine the number of solutions and the graphical formations of pair of linear equations. So here we are taking out the coefficients of x and putting it in a ratio form. Similarly, the coefficient of y and the constant terms, and we are comparing the ratios. So the first case is when the ratio of coefficient of x and y, if they are not equals, then you are going to conclude that the graphical formation will be intersecting lines, and hence it will have a unique solutions, and they can be called as consistent. Similarly, if you compare the ratio of the coefficients of x and y and the constant term, and you get that all the ratios are exactly same, then you will conclude that it will form a coincident lines, and it will have infinitely many solutions, and they can be called as dependent consistent. And the last one is if the ratio of x and y are similar, but they are not equals to the ratio of constant term, then you will conclude that they are parallel lines, and parallel lines has no solution and they can be named as inconsistent. So with this, we are done with the chapter number 3. Next video, we are going to talk about the examples and then the exercise of this chapter. Thank you.